On consideration of the evidence adduced and the submissions oral and written, on behalf of the parties, I conclude that the plaintiff's action is allowed and some of the remedies they seek should be granted. These reasons set out the bases for my conclusions, in particular my finding that, on the balance of probabilities, the defendants infringed a number of the claims under the plaintiff's Canadian patent number 1313830 by planting in 1998, without leave or license by the plaintiffs, canola fields with seed saved from the 1997 crop, which seed was known, or ought to have been known by the defendants, to be Roundup tolerant, and when tested was found to contain the gene and cells claimed under the plaintiff's patent. By selling the seed, harvested in 1998, the defendants further infringed the plaintiff's patent. So reads the headline paragraph of the landmark 2001 ruling between Monsanto Canada and Percy Schmeiser, a Canadian canola farmer who in 1998 grew and sold 1,000 acres of Round Up Ready canola. The Supreme Court of Canada found that Mr. Schmeiser had unlawfully infringed on the patent rights of Monsanto Inc. because he had knowingly grown a field of canola plants containing their patented transgenes. They also, however, found that Mr. Schmeiser owed no money to Monsanto because he did not actually benefit financially. Why would a one-time chemicals manufacturer spend several years and hundreds of thousands of dollars taking an ordinary canola farmer all the way to the Supreme Court of Canada? And why did that farmer bother planting a whole field of GMO crops if he didn't even benefit from it financially? And what in the world even is a Roundup Ready canola? Let's dig into it. Welcome to Modified. I'm your host, Dr. Orlando DeLange, ex-plant scientist and current science teacher. This podcast is my attempt to guide you through the science of GMOs and hopefully just enough of the history and the social context to give you a path forward in your own thinking. And if all else fails, I hope you'll enjoy some of the surprising stories and fascinating facts in the world of genetically modified plants. This is episode 13, Round Up Ready, the GMO that launched 1,000 lawsuits. I think it's best that we start with the basics. What actually is a Roundup Ready canola? Well, canola is the easy part. Canola is an oil crop. Canola is actually a marketing name, Canada Oil Low Acid. I think I talked about that in a previous episode. Canola is a true product of modern plant breeding. Agricultural geneticists developed it in the 1970s as a less bitter version of the millennia-old crop Brassica rapa, or rapeseed as it's known. Canola has a very mild taste and works as a cooking oil. You probably know that, you've probably used it. And you might have seen fields of the crop. The harvested part is the seeds, so you have to let it flower, and the flowers are actually a beautiful bright yellow that blankets millions of acres of Canada each summer. It is grown in many countries worldwide, but Canada remains number one. Canola was actually not the very first crop for which a Roundup Ready GMO variety was available. Apparently the Roundup Ready soybean, was just a little bit earlier, but that would have been a matter of weeks or months because they were both released in 1996. And the events of Schmeiser versus Monsanto rest on what happened in the very first years of the existence of the technology, and they were about canola, so I'm going to talk about canola in this episode, but we're also just going to generally learn about what Roundup Ready crops are. And it doesn't really matter that much about which crop we're talking about when it comes to Roundup Ready and how that works as a GMO trait. That's also a lot like the BT crops that we covered in last episode. And just like BT, Roundup Ready is one of the big success stories in terms of its longevity and its prevalence and the kind of amount of money it's made for its producers. And I would just say already at this point, Roundup Ready is the Monsanto brand name, now Bayer brand name, but there are many other companies now that make equivalents. The generic version is called glyphosate resistance. And actually just glyphosate resistance is one example of what is really the broader category of herbicide tolerance. So which is where a transgene is introduced to make crops resistant to a herbicide. If you're reading up about GMOs, herbicide tolerance is often shortened to just HT. So you might read about BT crops, where BT does stand for Bacillus thuringiensis, that bacterium that the toxin is taken from to basically make the plants themselves insecticidal. HT stands for herbicide tolerance, and there are some different versions of herbicide tolerance. Roundup Ready, or glyphosate resistance, was the first and I think still the most dominant. But between them, BT crops and HT crops are really the two dominant kinds of GMO crops, the ones that kind of made it through the first flurry of activity and innovation in the late 1990s and were a kind of success story and took off. And in many areas, many regions, and many crop types in those regions have become the vast majority of acres planted. And I'm talking about kinds here, like kinds of GMO crops, being deliberately vague, because in each case we're talking about hundreds of different crop varieties. So when I say BT crops, that means in practice lots and lots of different crop varieties, and all they share is that they all have a transgene inserted into their genomes, which makes them produce this toxin from bacteria, or in the case of HT crops, they all have a transgene inserted into their genome, which makes them tolerant to a herbicide. As discussed last episode, the first BT crops were produced by Monsanto, but today, many companies and government research facilities produce and distribute BT crops, and the same is true for HT. So Roundup Ready from Monsanto was the first to market, but is not the only player today. The situation is a little more complex for HT because this technology doesn't work by itself. BT crops are a standalone insect pest solution. HT crops only work when used with a specific corresponding herbicide, which is glyphosate in the case of the original Roundup Ready crops. And glyphosate, a chemical which is nothing genetically engineered, just a kind of chemical that you can synthesize using raw kind of organic chemistry ingredients. That herbicide was invented by Monsanto, and they held the patent on it until 2000. Weeds are a big deal. Home gardeners can get frustrated with weeds ruining the aesthetic properties of a lawn or a flower bed, but if you are a Canadian canola farmer, poorly managed weeds could mean a 30% drop in yield, which is really make or break for the financial viability of most farms. Weeds are just plants you don't want. Being a little more specific, it's plants you don't want that grow quickly and that propagate easily so they can become a persistent problem that you have to manage. That still does leave a lot of variety, a lot of different species that we can end up calling weeds. The reason weeds are such a problem in farming is that they are competitors to the plants that you do want to grow. They don't just compete for light, they also compete for water and soil nutrients. It might seem like weeds aren't that big of a deal. Unlike insects and microbes, you can easily see weeds and they can't hide or run away, so you can just pluck them out of the ground with the help of a simple metal tool. That works well enough at small scale, but when your crop is grown over hundreds of acres, that manual approach is not going to be realistic. So as farms begin to get bigger and bigger in the 20th century, with huge monoculture fields, traditional weed control methods were no longer sufficient, and chemical herbicides began to proliferate and get integrated into farming practice at scale after the Second World War. Spread onto fields just before sowing and as the crops germinate and begin to grow. Once crop plants are big enough, they can generally compete against the weeds without extra chemical help. Chemical herbicides also have a notorious history of as weapons of war. The most famous example being the Vietnam War. Agent Orange was the main herbicide used during the war, a cocktail of two herbicides actually, 2,4-D and 2,4,5-T, which together could kill pretty much any plant they came into contact with. Agent Orange was sprayed from helicopters over tens of thousands of square miles of Vietnamese forests and farmlands. The whole operation was known as Ranch Hand, with an aim communicated to the American public of removing forest cover for Viet Cong fighters. But from the beginning, farmland was targeted in order to literally starve the enemy forces, though in reality, this was food that fed civilian populations too, causing widespread food shortages. Unknown at the time, Agent Orange also contained an unwanted chemical side product, a chemical called dioxin. Dioxin is a known carcinogen, and exposure to Agent Orange has been linked to increased rates of cancer and birth defects for millions of people in Vietnam, as well as tens of thousands of American Vietnam War veterans. I mention Agent Orange because the companies that manufactured it for the war effort were the big players in agriculture, since they had the infrastructure to do this. Many companies participated, including Dow and also Monsanto, the maker of glyphosate and of glyphosate-tolerant GMO crops. And I'm not trying to suggest that Roundup Ready canola is a weapon of war, but I do want to demonstrate the ways that technoscientific systems are complex and interconnected. The same research and the same technology that produces chemical herbicides that allow the incredibly productive food systems seen today are the exact same as those that were used to destroy forests and to starve people as a weapon of war. So let's look at glyphosate, aka Roundup, and the Roundup Ready canola that Monsanto released in the late 1990s. Roundup is a brand name owned by Monsanto, which has been carried on after Bayer bought Monsanto in 2018. Bayer pretty swiftly removed the name Monsanto from the product lines it acquired, but it still kept individual brands such as Roundup. Roundup can have a range of different formulations. There are different versions of Roundup on offer, and the base formulation has changed over the years, but the key ingredient has always been glyphosate, a herbicide which Monsanto developed and patented in 1974. Herbicides are all chemicals that can kill plants, but they differ in their chemical composition and their mechanism of action. Glyphosate is a small molecule, just 3 carbon atoms, a phosphate and a nitrogen atom, with oxygen and hydrogen atoms attached at both ends. But with organic chemistry, the details really matter. Just rearranging 2 atoms can have a dramatic effect on properties, and there are 2 properties that really matter for glyphosate. One is that it can be easily absorbed through plant leaves, but not so much through roots. So if you spray it into a field, it will kill the growing plants, but it won't then remain in the soil and kill things that grow in the field after that. That makes it pretty useful as a herbicide that you can spray onto a field just before you then sow your crop. Even if you aren't sowing GMO crops resistant to glyphosate, you could still use it in that way. But absorption through leaves by itself isn't enough. It has to have a way to kill the plant once it's absorbed. Glyphosate is carried by the phloem, which is one of the 2 main vascular systems of the plant, and leads from leaves to growing points in the plant called meristems. In the meristems, the glyphosate molecule bumps around the cells until it finds its target, an enzyme called EPSP synthase. EPSP is 5-enol pyruval shikimate 3-phosphate. So I think it's best to just stick with the acronym, EPSP. And EPSP synthase is an enzyme that catalyzes a key step in the shikimate pathway. Unless you've studied plant biology or microbiology, there's almost no chance that you've heard of the shikimate pathway, and that's because it doesn't exist in animals, just in plants, fungi, and bacteria. It's a metabolic pathway that produces certain amino acids, which are the key building blocks of protein synthesis. And given that proteins are the molecular machines that make life possible, without a functioning shikimate pathway, plant cells will quickly die. In many ways, it's ideal for a herbicide to target a pathway that doesn't exist in animals. That way, it's impossible for it to accidentally harm beneficial insects, birds, or, well, us. In theory, that makes sense, but there could be secondary effects that may have nothing to do with the shikimate pathway, but could be harmful in animals. And there can be other chemicals used in the formulation that have negative effects on human health or the environment, as was so horrifically the case for Agent Orange. And that debate around the human health or other animal health impact of glyphosate has been going on for decades and is very much still ongoing. There have been thousands of peer-reviewed research papers written about glyphosate with a particular focus on its health and environmental impact. Despite that long history, there is still disagreement between experts, made much muddier by big players like Monsanto weighing in to fund and back researchers who might produce results that play well for them, and prompting researchers on what to write and what not to write in their papers, which is very much not good academic practice. A California jury in 2019 landed a huge blow against Monsanto, which had just been bought by Bayer at that point. They awarded $2 billion, that's billion with a B, to a husband and wife who for years had used Roundup in their home for weed control, and both husband and wife had developed non-Hodgkin's lymphoma, a form of cancer. The jury found that Monsanto had deliberately manipulated scientific research to suppress evidence of a carcinogenic effect of glyphosate, and that there was sufficient evidence to support that Roundup exposure was a significant factor in the couple's devastating cancer. Despite that, glyphosate is not banned in the US or in the EU, though several European countries have banned it for home use, and actually Vietnam, with its tragic experience of the dangers of herbicides, has fully banned it. Indeed, the World Health Organization declare that glyphosate is carcinogenic, a designation that is not backed by health agencies at the national level in most countries. I'd be happy to do a full episode just on this topic in future if folks are really interested. But for now, let's look back at how this all connects to GMOs via Roundup Ready crops, and then bring all that back to Schmeiser v. Monsanto, the lawsuit that we started this episode with. We've talked a lot already about Roundup Ready plants, and that they have been genetically engineered to be able to survive treatment with glyphosate-based herbicides. So I think it's time that I explained how you do this genetic trick. Monsanto scientists didn't just wish it into existence. I haven't been able to find any documentary evidence about exactly what was happening in Monsanto's genetic research labs in the late 1980s and early 1990s when they must have been developing this idea. But here's how I think it went down, based on what I can find, and as ever, I will link what I'm basing this on in the show notes on the website. Monsanto had a hugely successful herbicide with patent protection. You could spray it onto fields before you sow crops, and that would kill any weeds in the field, clearing the way for sowing, which is great, but weeds also grow alongside the germinating crop seeds at the early stage, and they can crowd out their seedlings. So ideally, you want to be able to spray again once the seeds are germinating to kill off the weeds. But glyphosate, unlike some other herbicides on the market, does not selectively kill only some kinds of plants. It really kills everything. But if there's a way that you could engineer the crops that they would survive glyphosate, be tolerant to it, then you could just spray the whole field and only your crops would survive. And what if you could sell the seeds and the herbicide as a package deal that you have patent control over from one company? And isn't that an incredibly lucrative sounding business model? Again, I can't prove this, but it seems very likely that the business model idea came first, and then they worked furiously to find a way to achieve it. But how could they achieve it? These days, and I mean really just within the last few years, computational tools have advanced to the point where it may be possible to design from scratch a totally synthetic protein that could bind to and destroy the glyphosate molecules in the cells. At least, if you already have some starting natural protein that binds and destroys a fairly similar target molecule. However, back in the 1980s, such technology was not even conceived of yet. But if you can't design the protein yourself in a computer, there's another great option. You can search through the catalogue of evolution, over 3 billion years worth of nature's trial and error. Just look for an organism out there that is already resistant to glyphosate, and then just work out which gene or genes allow them to do it. I mentioned already that glyphosate kills all plants. In the 1980s, there were no known plants resistant to glyphosate. And if you've heard about glyphosate-resistant weeds existing, you're not wrong, just put a pin in that for now. I also already mentioned that the shikimate pathway, which glyphosate targets, is not unique to plants. It's also found in bacteria. Bacteria are everywhere and very abundant, and one place you'll find plenty of bacteria is in any kind of waste runoff. And that is where the Monsanto scientists found their solution. A gene for glyphosate resistance was found inside a bacterium that was happily growing in an agricultural runoff pond in Louisiana, a pond that was packed full of glyphosate runoff from nearby fields. By definition, if the bacteria could grow there, then they must be resistant. I'm sure it took a lot of work by the scientific teams at Monsanto to work out exactly which gene was responsible. These days, such a project might be doable in a year or two by a single PhD student, but back then it probably took years of work and a whole team. But they isolated what proved to be a pretty logical genetic mechanism for resistance. The bacteria had a single genetic mutation at the active site of their ESPS gene. So remember, ESPS is the enzyme in the shikimate pathway that is targeted by glyphosate. This modified version of ESPS in the bacteria is basically immune. The glyphosate does bind to the enzyme, but it doesn't block the enzymatic function of the protein. And as a note, exactly how that works was only published in 2006, a decade after Roundup Ready crops had been on the market. So at the time when they were developing this product, they didn't know exactly how this version or this allele of ESPS was able to resist glyphosate. They just knew that it did. And so they took a gamble of a lot of time and a lot of money to get that gene out of the bacteria and use a gene gun to deliver it into Cali, first of soybeans and later, once they knew it worked, into canola and corn and others. They grew up the transgenic soybeans in test fields, sprayed them with glyphosate, and I like to imagine the dollar signs in the eyes of the top executives when they read the report of the results. Fields full of healthy soybean plants, untroubled by weeds which had been killed off by the glyphosate. So let me just recap. If you missed it or got lost, Roundup Ready plants still have the normal ESPS enzyme in their genomes and in their cells, and that still does get blocked by glyphosate, but they have an additional version of the gene. So it's pretty much the same gene, but with some slight DNA differences that cause some differences in the protein. And that gene that they have is borrowed from a specific strain of bacteria. And that version is resistant to the herbicide, allowing the transgenic plants to have a functional shikimate pathway and to survive treatment with glyphosate. One of the interesting twists in the story is the identity of the bacterium they borrowed the gene from. It was a strain of Agrobacterium tumefaciens. Devoted listeners will remember that name. It's the bacterium that is actually used as what we call a vector to deliver DNA into plant cells as one of the two main methods of plant transgenesis. It played another surprise and unconnected role in the history of GMO crops as the source of the gene in Roundup Ready plants. So I mentioned earlier that today, if you Google glyphosate-resistant plants, you'll find plenty of articles about that. And that's because the widespread use of glyphosate over decades has created the evolutionary pressure that has favored random mutations in the ESPS gene. And because Roundup, aka glyphosate, became more prevalent after the release of Roundup Ready GMO crops, this problem has gotten rapidly worse. I said earlier that 3 billion years of evolution just happened to create a glyphosate-resistant bacterium, which the Roundup Ready gene was taken from. But that's probably not true. Probably that genetic mutation was a relatively recent one, not something that took 3 billion years of evolution to evolve. It was probably quite recent, and it was selected for and became dominant in that population of bacteria because the bacteria happened to be growing near a waste pond full of glyphosate. It's the exact same logic as antibiotic resistance in bacteria, which many of us are familiar with, and for Bt resistance in insects, for that matter, if you remember from last episode. Basically, if you have some product or chemical that kills all individuals it comes into contact with, any individual with a random genetic mutation that allows them to survive will by definition be the only one left to pass their genes on to the next generation. And that's very easy in the case of bacteria. You don't need two bacteria to come together and mate. You just need one surviving bacterium that can then divide and divide and divide, producing genetically identical clones that will take over that local environment. And in a very similar way, weed species growing in an area with a lot of glyphosate use will have this huge pressure, what we call selective pressure, that will favor any rare random mutation that happens to make them able to survive treatment with glyphosate. And like bacteria, many plants are able to reproduce without a mate, meaning they do still need to have sexual reproduction, but pollen and eggs from one plant can mix and mingle and produce seeds. And that's more common in weeds than it is for plants generally. Though that's not going to be the case for all weeds. And I haven't double-checked this, but I'm pretty sure that the glyphosate-tolerant weeds are going to be more likely to be selfing, as we call it, this ability to basically reproduce with yourself to produce viable seeds. This may sound familiar from the last episode on Bt crops, but there is a slight difference in how this resistance evolution works. There are many, many versions of the Bt toxin gene, and that provides the GMO crop breeders with options in case insects in one region develop resistance to a particular Bt toxin. However, there is just one glyphosate, so once the weeds are resistant to it, that is a significant problem. One that has so far not rendered glyphosate-resistant crops useless and has not stopped farmers totally from buying them, but is becoming more and more of a problem. It's significant enough that over the last few decades, a number of companies have developed and released crop lines resistant to other herbicides to make sure the whole kind of system doesn't just rely on glyphosate. I've kept things pretty simple in this episode by just focusing on the first and most famous commercially successful herbicide-tolerant GMO crop, and that is Round Up Ready, and its matching herbicide Roundup. But there are by now plenty of different crop varieties, not just resistant to glyphosate, not just developed and sold by Monsanto, but there is still nowhere near the huge diversity of Bt toxins. And herbicide resistance in weeds does remain a significant problem for the whole kind of model of GMO herbicide-tolerant crops. There is a lot more we could talk about when it comes to Roundup Ready plants, but I want to bring this episode to a close by coming back to Percy Schmeiser and his famous legal loss in the Supreme Court of Canada. The case was all about this one farmer, Percy Schmeiser, who was found to have knowingly grown patented seed without paying for access, all the way to the Supreme Court to fight one farm and one farmer about what was likely a few $1,000s worth of lost revenue for Monsanto. Seems kind of wild. Except, of course, this lawsuit was actually one of hundreds of similar lawsuits in North America over the 1990s and 2000s. The Schmeiser case was just the most significant of a whole batch of similar lawsuits at the time. My gut feeling is that these seemingly relentless... My gut feeling is that these seemingly relentless lawsuits really soured people on GMO crops perhaps more than anything else. Aggressive litigation to protect patents and copyright is nothing new. It's been a part of life for centuries in all sorts of areas of human activity, from pop music to industrial ball bearings. However, crops are not ball bearings. They are our food. They are our survival, and they are a central element of our culture and therefore of our identity. So the image of an army of lawyers descending on farmers and dragging them to court in order to defend a product that is at its heart about exerting as much control as possible over the purchasing decisions of farmers just does not sit well with people. There are two things in particular that I think got people really angry about the Schmeiser case. One that is based on a lie, and one that does really hold true. The lie is that Schmeiser was sued by Monsanto for seed that accidentally blew into his field. That was an initial defense that Schmeiser put forth and kind of entered the court record and public record, but he retracted it and explained that he had in fact knowingly harvested GMO canola from the roadside of a neighboring field and had then grown up enough plants from that seed to be able to have enough seed to plant his fields at scale the following year with this illegally harvested GMO canola. But just like seeds, once the idea of accidental contamination had been planted in people's minds, it grew, and it is still regularly repeated. And I do want to clarify, it is true that GMO seed does end up getting into neighboring fields. But as far as I can find out, I did look for this, there does not seem to be any evidence of Monsanto or other companies having pursued litigation against a farmer in a case that is truly accidental contamination. However, I mentioned there was kind of two big things that got people very angry. The other one really can't be denied, which is that Monsanto employees were sampling fields in rural Canada looking for patent infringement. Schmeiser didn't just sort of tell the wrong person who then went and told Monsanto on him, no. As a matter of court record, the Monsanto field agents sampled the DNA of plants growing right at the edge of his property. And it's not a minor side note, it was actually a big part of the lawsuit, because Schmeiser countersued Monsanto for trespass, saying that they had legally entered his fields to take their samples. Monsanto successfully argued that they had taken samples from plants that were growing just over the property line, but since all of those plants turned out to be positive using PCR tests to check for the presence of the transgenic ESPS gene, they could be sure that all the plants in the field were Roundup Ready canola. Since I can't find any other explanation for why they specifically pursued Schmeiser, I think it's a very logical assumption that Monsanto was sending agents round fields all across areas of Canada that they knew were growing a lot of their product, and that they were looking for people like Schmeiser who might have not themselves purchased the GMO seed from Monsanto, but instead taken some from their neighbors and grown it up to grow on their own fields. It makes sense from a business perspective. And like I say, patent protection is part of our economic system. But once again, food crops are not products like any other. I was going to end this episode here, but there's actually a couple of updates hot off the presses I wanted to make sure I included. In mid-February 2026, so just last week as of recording, Bayer announced a new $7 billion payout that will be used to provide compensation to anyone who has developed non-Hodgkin's lymphoma and can prove that they had exposure to glyphosate. That is a way for them to avoid having to legally accept responsibility. Basically, they're just financially settling thousands of lawsuits in one go. And yet, in exactly the same week as that announcement, President Trump signed an executive order requiring the USDA to legally protect glyphosate retailers. It's really unclear to me how that would work when even the biggest manufacturer, Bayer, seems to think that the odds are against them and that they are forced to make these payouts. Clearly, the fight over the human health impacts of glyphosate is ongoing. When it comes to GMOs, there is a confusing patchwork of claim and counterclaim. Some arguments against GMO crops are based on misunderstandings, or, such as in the case of Bt crops and their impacts on monarch butterflies, based on one poorly designed study that then kind of catches on and gets repeated over and over again. But there are many arguments that are irrefutable. The big corporate producers of GMO seed, most notably Monsanto, really do aggressively protect their patents and are happy to take farmers to court over it. And Round Up Ready crops, at least the original glyphosate-resistant versions, really did promote the use of a herbicide that, at least based on the huge payouts and some studies, does indeed seem to be carcinogenic. Okay, we'll leave this story for now. We still have a few more episodes in Season 1, but as we move into Season 2, we'll still get plenty of science, but the focus will shift more onto the business and social impacts of GMOs. And so much of that hinges on the way that the technology and business models of GMO crops so transparently reveal that in contemporary agricultural systems, food is a product and farming is a business. That is not a reality that began with GMOs, but it is one that they have made more stark. I had 3 more episodes planned to round out this season. A Your Questions Answered episode, then an unusual episode which will be a quick run-through of some of the other kinds of GMOs commercially available that are not Bt or HT, and I'll end with an introduction of CRISPR and the possible new age of gene-edited plants that comes with that. I haven't written the CRISPR episode yet, and knowing me, it may well end up extending into 2 episodes because CRISPR is pretty cool and there's probably a lot to say. But still, we are definitely approaching the end of Season 1. And I will need a fair amount of time to work on Season 2. I have a lot of research to do. I don't know everything that will end up in an episode next season. But for sure, I already know and have decided that you'll be finding out about how the Green Revolution spread dwarf wheat to Mexico, how idealistic scientists created golden rice, and how America's 33rd Vice President changed the face of agriculture forever, alongside many other stories. But like I said, we still have a little ways to go, and what's coming up fast is episode 14, which will be a special episode of me answering your questions on anything related to GMOs. So you still have a few more days if you want to send those questions in to orlando@modifiedpod.com. That's orlando@modifiedpod.com. You could also send me a message on Instagram or Blue Sky. You can find my handles on the website of the podcast, which is www.modifiedpod.com. I want to particularly acknowledge a few sources for this episode. Reddy and Nandula's 2012 article, Herbicide-Resistant Crops, History, Development and Current Technologies from the Indian Journal of Agronomy, and the Federal Court of Canada, where you can find the full text of the 2001 decision on Monsanto versus Schmeiser. So to wrap up, here are your 5 take-home messages. Number 1. Monsanto pioneered the lucrative area of herbicide-tolerant GMO crops with Round Up Ready soybean and canola in the mid-1990s. Alongside Bt, herbicide-tolerant crops are one of the 2 kinds of GMO crops that since the 2000s have dominated the GMO crop trade and represent big chunks of total global production for crops like corn, soybean and canola. Number 3. Glyphosate is a herbicide developed by Monsanto in the 1970s. It is a broad-spectrum plant killer that inhibits the function of the enzyme ESPS, which is part of the essential shikimate pathway. Number 4. Roundup Ready crops are resistant to the herbicide glyphosate. This is because they contain a version of the ASPS enzyme that is not inhibited by glyphosate. Number 5. There have been hundreds of lawsuits in which Monsanto pursued farmers for growing GMO seed without purchasing it from the company. Okay, that'll do for now. Bye!